The Hard Rock Hotel in New Orleans was in the process of being built and was approximately 18 floors tall. At 9:15 a.m. on October 12, 2019, the support beams on the 16th floor gave out and resulted in the building's collapse and death of multiple workers.
Oh my God.
Panic and mass confusion in the heart of New Orleans. This morning, the upper floors of the Hard Rock Hotel, currently under construction, suddenly began to crumble. First responders scrambled to the scene.
I need as many units as I can over to my location. We need to move all this ground as far back as possible.
Dozens of construction workers were inside the building as the concrete floors collapsed on top of each other.
Not only were buildings, vehicles, pedestrians, historical landmarks, transportation routes, and many other groups affected by the collapse, but 3 construction workers lost their life as well. A section of downtown New Orleans was shut down for more than a year, increasing the amount of traffic in the city. It was nearly 2 years later when the site and surrounding areas were recovered back to normal.
Portions of the top floors collapsed, resulting in several floors pancaking into each other. The 14th and 16th floor were the transfer floors, thus having different layouts. These floors were to have better supports, along with more decking and support beams, in order to make up for the weight distribution. The 16th floor had failures with connecting columns to beams, which inevitably made the structure give out. The images shown above reveal how unstable the building was as a whole. The plans for the site were drawn out but not correctly followed, as changes were made and protocols were not followed. The approved plans include a 3-inch metal deck, but it was a 1 to 2-inch deck that was substituted instead. There were many mistakes made, such as not installing studs into beams, pile loads holding more of their weight than what was calculated, and the substitution of materials.
81 beams supporting the 16th floor were not up to code, and dozens of them were grossly undersized. A structural engineer, Walter Zanier, calculated that the beams were nearly 300% overstressed. Construction workers took notice of the visible distress on the support beams, but nothing was done. The workers needed to be correctly trained and supervised should an incident occur. The construction agency failed to properly document not only the calculations of the stress-strain relationship of the beams and its effects, but failed to include changes of the plans with permitting offices and inspections.
A 16-gauge heavyweight decking was approved by the city. However, the decking used was a 22-gauge lightweight decking. The decking would have withstood if the span between each support beam was only 23 feet 7 inches, but they were all about at least 26 feet apart.
A thicker, stronger type of decking, 16-gauge, was planned to be used in order to support the weight of the concrete that had been poured on the upper floors. The construction company instead used a thinner 22-gauge deck because it was a cheaper alternative, yet they didn't inform the permitting offices. The 22-gauge decking would have been more appropriate had they utilized more support beams, as the weight of the concrete and 2 floors above it were too heavy for the beams to hold. The images above reveal a depiction of the effects of using a thinner beam compared to a thicker steel beam.
These images reveal how normal constructed balconies are built. There is more supported beams built for the cantilever balconies. Usually balconies are made of decking concrete with steel rebar in order to maintain the weight of the balcony's pulls. However, in the Hard Rock Hotel, no rebar was inserted in the concrete, along with thinner concrete decking.
Using the material selection method, one can determine that a carbon and alloy steel could have been utilized, as well as the reinforcements previously stated. Using carbon and steel alloys meet all the necessary requirements, such as easily fabricated, having a high resistance to heat and corrosion, as well as being more tough and elastic than commonly used mild steel. A lower gauge decking and a decrease in space between support columns could have lowered and minimized the probability of a collapse. In the future, construction projects should be properly supervised and follow the plans that initially got approved. Preventative and safety measures should have been used in guidance with OSHA requirements. The Hard Rock Hotel incident was an easily avoidable situation in which a lot of necessary yet simple things were overlooked and led to the building's deterioration. This unfortunate occurrence is undoubtedly a learning lesson for all those involved in construction agencies in the future.